Let's calculate a product of two square roots of negative numbers and see what the result is. And then as we look at this, we will see why some people think there are proofs that 1 equals negative 1. So let's go to the menu and we'll go to Run Matrix and we'll calculate the square root of negative 4 times the square root of negative 9. And before I push the execute key, why don't you guess what the product is? You might guess that negative 4 times negative 9 is 36, and therefore the square root of negative 4 times square root of negative 9 is positive 36. Wrong. First error is that the calculator reports a non-real mistake, that you can't even do it. There's a way to make calculators obey, and it's to go to the settings menu and change the complex mode from real to the complex form a plus bi. So we didn't get it right before, but let's try it again. Square root of negative 4 times square root of negative 9 is not at all what we expect. It's negative 6. Now what happened here? Why did we think it was positive 6 and yet the answer turns out to be negative 6? Well, let's examine the square root of negative 4 individually. There's the reason. The square root of negative 4 is 2i. And the square root of negative 9, you guess, is 3i. And we all know that 2i times 3i is negative 6, because it's 6i squared. So what's the upshot of all of this? Well, the principle is that the square root of x times the square root of y equals the square root of x times y whenever x and y are positive, or if x or y is 0, or if one of them is positive and the other is negative, but it fails when they're both negative. The square root of x times the square root of y equals the square root of xy is false for x and y both negative. And this is the exact reason some people have purported proofs that 1 equals negative 1. They apply this principle mistakenly and come up with incorrect answers. Done.